and welcome to 4.3 Graphing Proportional Relationships. We're going to be talking about how one thing changes and affects how the other changes. So, when we talk about unit rate, you may have seen this in many real life contexts. We might be talking about miles per gallon, or we might be talking about how much you make per hour, right? We might also be comparing the total cost that you spent on, let's say, concert tickets, and we might write that in cost per ticket. Okay, so let's look at what that would look like for some graphs. If we were talking about miles per gallon, and let's say you had a car that got 10 miles per gallon, you would plot how many miles you had gone when you used 1 gallon, 2 gallons, 3 gallons, and 4 gallons. So you would see that starting at zero, you had used no gallons, right? No gallons, and you had traveled 0 miles. So if we draw a line here, we should have a straight line that goes like that. And if we were to examine our unit rate, we would say that you go 10 miles per gallon. That would be our unit rate. Now, if we were to look at the slope of the graph, we would see that for every one we go over, we go up 10. Now, really quickly, I need you to know that the slope is rise over run, okay? Or the change in the y value over the change in the x value. So let's look at how far we go up. We go up 10 over 1, okay? Up 20 over 2, okay? So we could say 10 over 1 is our slope. Now let's see if we can make a connection between our slope and our unit rate. Hey, it looks the same. So what you're used to seeing as unit rate on the graph is also our slope. Now you'll notice that the miles is here on the y-axis, and that comes first when we're talking about slope because it's the change in y over the change in x. So we could say 10 miles per 1 gallon, but that reduces down to a slope of 10, with our units being miles per gallon. All right, now let's imagine that you have a really great job testing Christmas cookie samples and you actually get paid for it. You earn $8.50 per hour for testing these Christmas cookie samples. So after 1 hour, you would have $8.50, right? After 2 hours, you would have $17. Lucky you, and a stomach ache. If you're still at it eating cookies 3 hours later, you would have 25.50. And at 4 hours, you would have $34. So if we were to plot these points on the line, are on our graph, you would see we have one about right there, two at 17, three at 25.5, four at 34, and we'll put that right there. Then if we were to draw a line, you would see that the rate increases at a steady 8.50 per hour. So if we were to write that as a unit rate, we would say you earn 8.50 per hour, right? Now, if we were to analyze the slope of this graph, you notice we have different units here along the bottom. It increases by 1, 2, 3, 4, 5. Here it increases by 10, right? So we have to be really careful to look at our units and understand the problem and what it's asking. So as we look at y values, y goes up 8.5 as x increases 1. So if we were to write the slope would be 8.5 because it goes up 8.5 for every one that it increases along the x-axis. Remember, it's the change in y over the change in x. Okay? So we would say there is direct variation represented by this graph here. Now, a key thing for you to know about direct variation is that it has to pass through the point 0, 0. Okay? Because if you have done 0 hours of work, you've earned no money. But as you continue to work hour after hour eating all these cookies, you earn a steady rate or a constant rate, okay? That would again be called our unit rate. And you would also notice that that unit rate is equal to our slope. Okay, now just for fun, we're going to pretend that you have to run a certain number of miles to work off each cookie. So I'm going to plot some points here on the graph and see if you can figure out how many miles you'd have to run to work off each cookie. So these are our points. If we get a straight edge, we could connect these points at that with a line that looks like that. Okay, so if you eat 2 cookies, you would have to run 1 mile to work it off. If you eat 4 cookies, you would have to run 2 miles to work it off. Now you'll notice this is going to pass through point 0, 0. And if it has a constant slope, we would say there is a direct variation between the number of miles you have to run and the amount of cookies you eat, right? So let's look at it because remember, it's the change in y over the change in x. So let's look at how far up we go on the y-axis and how far over we go on the x-axis. So we go up 1 over 2, okay? So you might say you have to run 1 mile per every 2 cookies, okay? Now that would be our unit rate. If we were to talk about slope, change in y over change in x, we would see that that is 1 mile for every 2 cookies. So our unit rate and our slope are the same for this graph. Now, if we were to write the equation of the line, we could write it like this, that our y equals 1/2 whatever our x is. Do you see that? Because if x is 2, y is 1. Okay, so let's test this, right? 1/2, y is 2. Would that equal 1? Is that true? Yes, it is true. So you're seeing that we can use this slope to figure out what our x and y coordinates are. Now, this is for direct variation where we assume that we are going through 0, 0. So our y-intercept is actually here at 0, but we don't have to write that in the graph. So for direct variation, you need to know that you can write the equation of a line in this form, y equals mx, where m is your slope. Okay, so if you know that your slope is 1/2, you would know that any y value is going to be half of what your x value is. So let's test some points. If x is 10, what would y be? 1/2 of 10 would be 5. So that point would lie on this line. Okay, now even though our graph doesn't have this point 10, 5 on there, if we were to continue on and continue this line up, we would find that somewhere out here we do have that point 10, 5. But knowing the equation of the line, we don't have to build a giant graph. We can just solve for points that would lie on that line given this equation. Now this is y equals mx. That's your equation to show direct variation, and it passes through point 0, 0. This is critical as you do your homework. You have to know that for direct variation, it has to pass through the origin, which is also known as this point 0, 0. That's all you need to know for today. Good luck with your homework. You're going to find this really helps you in solving a lot of real life equations.